Okay, so here we are recording. Alright, so you'll download the drawing on Blackboard that is entitled J-4. It's 130 Cad F11 DG Prob J-4. You'll see it as an item in the new folder. Then you'll also, at some point, you need to go back and review or survey the information on descriptive geometry on your CD in supplemental on the basic principles of it. And then you can refer back to it for you can refer back to it as a review on how to do something. Basically, we're going to run through the theory of descriptive geometry with several sheets. Descriptive geometry is the foundation of technical drawing. We wouldn't have orthographic projection, we wouldn't have the Industrial Revolution would not have occurred if a French physicist, mathematician kind of person had not dreamed this up. Okay? Gaspard Monge is the one that invented descriptive geometry as we have it today, back in the 1600s. He was challenged by the government to design a fort that could not be attacked by the current ballistics of the day. And so he calculated how high the walls should be and trajectories back then. And came up with, in the process, a way of creating drawings. Because a lot of drawings back then were artistic. Were no really technical kind of drawings. And there were some other ideas floating around out there. So, and he did it at a very young age. And had he not been challenged with that particular job, that project, necessity is the mother of invention, So had he not been challenged, who knows how many decades it might have been before somebody may have come up with this technique for drawing, which would have delayed the Industrial Revolution. Might not have happened. So it's intriguing to think about things happening when they did, and what if they hadn't? What if that particular invention or technique or procedure wasn't discovered? Then where would we be? We might not be sitting here. At any rate, what you have on your screen when you open it is this.
Hopefully.
Is it coming?
No, I'm getting a big white screen.
Totally white?
Yeah, it's at the elearning.kcts.edu.
Oh, okay.
It's got a white screen. It's not even problem J4. Yeah, it says attached files. It's coming up on a white screen.
So, thanks to Mr. Monge, we have descriptive geometry, and then technical drawing was developed after that. So, the ability to view things at right angles and learning how to project them with this glass box or folding line theory came first. And then all the standards and lots of the technical drawing technique came much later. So that was back in the late 1600s. So this set of drawings we're going to begin with, called J drawings, because it's from Unit J of a workbook. By the way, you all should see a little drawing in there, right?
Oh, yeah. I see
Okay.
that.
Okay, good. It took me a while to learn how to do that in AutoCAD, where you have to copy and paste, and and you have to paste it from a Word document to really make it work good. Otherwise, AutoCAD loses its pathway to it, and if you don't have it in the exact same folder that it was originally inserted with. Okay? So, what I've done is created a layout sheet with a viewport. And if you click over to Model Space, you'll see a single sheet with three drawings to do, three problems. So what I've done is I've created three layouts so that you can easily draw right on top of the layout, on top of the raster picture file here in layout space. You'll never activate the viewport. Okay, you'll be drawing out here all the time in paper space. So there's problem J48 and then J49. So there's only three problems to do, but don't let the simplicity of it deceive you. Okay? Now, essentially we're learning what you've been doing in auxiliary views, but now we're just doing one line, one element, and then we'll do two lines and how they behave. All right? So we're picking it apart now. You've been using these theories and procedures. Now we're going back into it at almost like the beginning, and you're focusing on an element, because all of your drawings that you've done so far, they're all made up of points and lines and arcs, of course, okay, and circles. So now we're just looking at how do we do one line, and our job on this one is to find the true length of line A-B. So here we have in front of us two lines, and when we look at it from the top view, it's skewed or angled, and we look at it from the front view, and that same exact line, see, it's labeled AB, it's also skewed. So in the theory of projection, when you see a line in a top, in a front, or in two views, and it's angled in both views, when you see that, that means, aha, it is an oblique element, okay, because it's angled in two views and they're not the same length in either view. So to begin, following the procedure for descriptive geometry, whenever we want to see a line in true length or any surface in true length, our fold line has to be parallel. Okay? So we're going to create a line that's parallel, and we're going to make it a fold line. So I'll just go up here, and I've got lots of cool layers developed for you already. So here's fold line 1. So we'll start off with fold line 1, and that's going to be this one. And we'll just draw right on top of it. Now you can't click on it unless you have AutoCAD raster installed. Then you actually can connect to a raster image. So I'm going to draw right over top of it. Go to line, and I just zoom up and I try to pick about the middle of the line, and ortho is turned on, and I'm going to end over here. Now you look at it and you go, man, that's not really on top of that fold line. Well, that's okay for this type of assignment. setup, it's really all right. We're going to call this our fold line, and this is going to become the new orthographic horizontal line for our fold line. Okay. Then this line here, I'm going to draw a line on top of it and recreate that line. So that, of course, is an object line. Where, there he is, OBJ. So I draw on top of it. And so I just got to kind of pick generally in the center of it. Okay. Once again, this is going to become, whoop, this is going to become the new line that I'm going to work off of. Okay, so it's going to be right in the middle of that vertical little piece of line. Okay, of course it doesn't show up very well. I'm going to make it a red. Maybe it'll show up. Yeah. There we go. So I can see where I've put it. And let's see about this one. It is by layer. It is phantom. Probably wouldn't hurt to maybe give it a little color too. Yeah. The line type scale might need to be set. LTS, enter. 0.5. Yep. So that brings in the line type. You can see it right there. Alright. Then we're going to create a fold line parallel to this one. The purpose is when we fold parallel to any feature, then that feature will be true size in the adjacent view. So this will be fold line 2. I'll go ahead and assign a color to it. That looks good. Any color you want to make it. So I'm going to begin by drawing a line on, by offsetting this line up here a comfortable distance. Okay. So offset, and I'll just pick 2 points, something up this way. Offset that line up there. Okay. And then set that to fold line 2. Whoops. Try that again. Fold line 2. And then probably need to stretch him out a little bit. There we go. I have the extension snap turned on. So when you do, and you do the advanced or the hot grip editing, then you get a little projection line letting you know that you're at the same angle when you stretch something out. Okay? Alright, now we're going to do projections. So I'm going to project this way. Alright, do I need to? No, I can probably tell what I need to do, but I might need it where that projector crosses the fold line so I can make a measurement easier. So switch layers to projection 1, and that'll be here in the primary views. Oh, you know what? I need an object line down here. So object line. Now we have to do a little editing here since we're kind of picking our own endpoints, just really arbitrary. We're going to need to make sure these are projected points. So now I'd switch back to projection 1. Okay, go to line, attach to that endpoint, turn on ortho, and just run past that point. I'm not meeting it. All right, and do the same thing here to the end point of that line and run past it. So I may have to trim or extend a little bit. I'm going to turn off my line weights momentarily. Yeah. So I need to extend. And it's in there somewhere. There it goes. It's a little hard to pick sometimes. Okay. And then this is also extend. Alright. And they can run past it, it won't matter down there. It's a projector. Okay, and it's just real pretty colors. Alright, now I got to go this way with projection system 2. Alright. And we need to turn on our perpendicular snap to use. Let's see. Yeah. And we project to there. And project from that endpoint to here using perpendicular. Alright. Now we're going to extend those lines on out. Somewhere out there. Like so. Don't know if I got them long enough or not. We'll find out. Then we're going to transfer this distance, okay, to here. So we'd use offset, and I'm going to measure the distance from the fold line to point A, and then transfer that by virtue of an offset of the fold line. Just do it that way. Then I do the other one. Measure from the fold line to the end point. Be sure it's the end point. Yeah, right there. And then offset the fold line, the original fold line, not the one you just offset. Oop. So it's a little bit short. Okay. So A was right here and B is up here. Okay, near the edge of the viewport. So let's go ahead and extend that. And then instead of these lines, I'll get rid of these projection lines or offset fold lines in a moment. All right, now I go back to, in this case, I'm going to use auxiliary, okay, layer, and draw my new line up here. That looks like it needs a little thickness added to it, doesn't it? Auxiliary, yeah. All right. Okay, and then the true length measurement. So switch to the dimension layer. Sorry, I just coughed in the microphone, so whoever's watching this just got their ear filled full of phlegm. All right, annotate, dimension. Let's see. Oh, I want aligned. Okay, so you should come up with something on that order there. Okay, something close to that. Yours will be a little different than mine, or your partner, or your classmate, because it depends on where you pick and set this up. That's all right. All right, then, now, you'll fill out all of this, and then you will go to your plot. I have to do it down here. I got little helps up there. Go to your page setup manager, and let's create a new one, new page setup, and we'll just leave it as setup 1. Click OK. You can name it PDF if you want. So what we're going to do is plot it using the PDF print configuration. So it's DWG to PDF. It's going to be the ANSI A, plotting the layout, and everything should be pretty much default. You do want the ACAD colors, so the color table, and preview it, and it should look something like that. Okay, and you'll plot it to a PDF file. When you click OK, this is just page setup. That'll become setup 1, and when you do the next drawing, you can choose that as the setup. Okay, now I'm going to plot it. Plot preview. Remember, always preview before you plot. Pick plot. Then it'll prompt you for a file name in a moment. Oh, of course, that would depend on selecting the proper.
What style?
Yeah, I thought that was the default, so apparently not. Set current. Alright, now let's preview that. So I got a nice little drawing coming out back there in my printer. Now let's see if it goes to the PDF. There we go. So it'll come up and it'll say, kind of odd, browse for a plot file. Well, basically you're saving it as a PDF document. It'll add the name for you and stick PDF on the end of it, so you will need to put your initials on it. Okay, and put it in your folder wherever you like to save your course files. Let's see where in the world that is. It's on this computer's desktop. Put it over here. Great, and then after it plots, it should open up Adobe Reader and give you a snapshot, or actually show you what it looks like when it's finished. Okay. Questions? If you go over here to model space, there ain't nothing there. Now you will need to, one little detail, you will need to add labels to the endpoints. It's not super complicated for me to figure out that you've done it right on this one, but a little bit later even for yourself, you're going to want to have labels on the points. Okay? Is it next sheet after this, not the J4 but J5, it will get a little complicated. All right? So that's J4-7. This one, find the true length and point view of line CD. So you got the same thing, only different. And then J4-9. Oh, find the true lengths and point views of parallel lines. Okay, so same procedure. Okay, you'll project down this way. Don't go too far with your first fold line. All right, and you'll find the true length of these parallel lines. So it's like double your pleasure and double your fun. Double mint, double mint, double mint gum. Some of you know what that is. And then after you find the true length of these lines, then you'll project, you'll create a fold line perpendicular to them. Okay? Now if you're concerned about exactly how that looks, you can look in your chapter and it shows you an example of that. Finding the point view. Okay? That's in your CD chapter. So you find the true length of them just like we did on the first one. Then your next fold line will be perpendicular, not parallel to the line, but your second auxiliary is perpendicular to the true length line. And this is the procedure that you've been using all along for primary and auxiliary view drawings. Parallel, and then perpendicular to find the point views, which are part of a surface. Okay? So if you have any difficulty or questions about creating this, first consult your Descriptive Geometry chapter on the CD, and then email me or call me or text me or whatever. 2 cans in a string, whatever.
For some of us.
Yeah, or throw a rock on top of my house or something. Small one, small rock. All right. Then you'll, after you do the PDFs, then you'll stick those in the appropriate folder in your Blackboard